Assalamu alaikum warahmatullahi wabarakatuh. This is Dr. El-Moursy again in the microprocessor class. In the last lecture, lecture number 19, part 1, we have covered the how to implement for loops in assembly language. Today, we will go to the next programming control in high-level language, which are the do-while or the while loops. While loops, this is actually lecture 19, part 2. This is lecture 19, part 2. So as we maybe indicated in the last lecture, we have four paradigms that we want to see how can I use or utilize the the two instructions that we have, the compare and the different conditional branch instructions, in order to implement them in the assembly language. We have four controls in the high-level language. We have the for loops, we have the do-while loops, we have the switch cases, and we have the if-else statements. For loops and while loops have some similarity. If-else statements and switch cases are also similar to each other. So in lecture number 19, part 1, we covered the for loops, and today we are covering the while loops. What is the difference between while loops and for loops? The only difference between while loops and for loops is that in for loops, you know the number of iterations beforehand. So while you are writing the code for the for loop, you already know how many iterations you will go through in the for loop. This is not the case for the while loop. The while loop, based on the calculation that you are doing in the while loop, the number of iterations may change depends on the numbers. And there is no need for the programmer to go beforehand, before or while he is writing the code, to calculate the number of iterations. The while loop automatically will check for a condition. If the condition is true, the while should continue. If the condition is false, the while should terminate. We have in high-level language programming two flavors of whiles. We have what's called the while loop and what's called the do-while loop. We also wanted to shed some light about the difference between those two. However, we will first demonstrate the direct one or the easy one, which is the do-while loop. In the do-while loop, here is actually our high-level language, high-level programming. I'm writing here a syntax that is very close to the C and C++. Okay, so for the do while, I have do, and I open brackets. Okay, and I have my code. Okay, and I have closed brackets, and I have this code should be done while some condition. So the do while will perform some code. We can call it maybe code A. If the condition is valid, is satisfied, is evaluated as true, that means I will continue in looping or in the while iterations. If the condition is false, I want to stop the looping or the while and exits from the code, from the looping. You will not go back. So if I have here maybe code B. That means as long as the condition is evaluated as true, let us just, I will rewrite this in a different color to avoid confusion between the code and the evaluation. Okay, so we have here, this is my code. If the condition is true, if I continue loop or the while iterations. If the condition is false, stop. Okay, play the go back, go back to code A. Here, if the condition is false, stop and continue after the iteration. To يبقى code for B. We have to understand the while loop before we go and check any implementation that we will do in the high level language or in the assembly language. So here is the assembly. Okay? Remember something, and I am reiterating this many times. Conditional jump instructions. If the condition is evaluated as true, that means I will jump. If the condition is evaluated as false, I will not jump. So you have to logically understand the difference between what you do in the high-level language and what you do in the assembly. Condition is true means loop again. Condition false means don't loop and continue. The conditional is doing, okay, is actually, if the condition for the jump is evaluated as true, so that means I will jump, okay, which kind of matching what we are doing here. If it is evaluated as false, I will not jump and continue. So this flow of code match somehow the assembly. Okay, so in order to kind of evaluating this, let us take a more kind of a practical example. In order to do that, I will just demonstrate this for you through an example. Okay, so now we will remove the condition. Okay, let me just put this code a little bit higher here to give me some space. If I have do, okay, code A. After doing code A, I want to maybe modify parameters, assuming that I have parameter called A, okay, and A equals to maybe A plus B, okay, and I have here the condition if A is maybe, now let us take another maybe when A equals to the value of C, okay, while let's say since A cumulative, while A is smaller than, okay, since we are doing accumulation of addition here, let's say A is less than, okay, some value C. So as long as, okay, so this loop will be performed at least once, A will be, okay, added to the value of A, B will be added to A and will be placed in B, and let's assume that A and B are fitting even after the accumulation to 1 byte. Okay, so that means, okay, And so assume that A, in this example, let me just put some comment here. A, B, and C are all fit in one byte. Why this is important? Because this accumulation, I want to guarantee there is no overflow will happen, or there is no overflow will happen for this. So according to this assumption, okay, that means each time I'm adding B to A, okay, I will get a new value for A. I'm comparing A to C, okay. Now, while A is less than C, I will continue in the loop. How can I perform this in assembly? So now we have to do some assumptions. Assume, so for that assembly, I will assume here, I will put also some assumptions. And I assume that LA is actually in AL, and B is in AH, and C is in BL. Okay? Assume that I have those registers already carry the three values of A, B, and C. Can I perform the code here? Can I convert this high-level language to an assembly? The answer is yes. Okay, so I have to have a starting point for my code of A. Okay, so assume that I have here a label for code A. Okay, and here I have some lines of code. Now I want to start modifying A. A is in AL. Okay, I want to add to it the value of AH, and in order to calculate the new AL. Okay, so I will do add AL, comma AH. Now this instruction is being converted to assembly. Now I want to compare between AL and the BL. Okay, as long as AL is smaller than BL, okay, I have to continue in looping. Okay, so now compare. طبعا هنا let's assume that A, B, and C are all unsigned numbers. Okay, assuming that they are unsigned numbers. So I will compare AL and BL. This compare will update automatically the 4 bits of the overflow sign, 0, and the carry. Now, after the compare directly, I have to use the jump instruction. The question here, okay, which jump instruction to use? From this table, I'm talking about unsigned numbers, okay? And remember that the jump instruction will jump if the condition is evaluated as true. The condition that I want to check here is that I need to see whether AL is smaller than BL or not. Smaller for unsigned, through this table, I have to use below. If it is below, what shall I want? What shall I do? I want here to continue in looping. Similarly here, I want it to jump. So jump if below, okay, I have to jump to where? To code A. So that means this is exactly matching this. Jump if below to code A. And I will continue with code A. Here is the code for A, okay? Here is the code for A, and at the end of the code for A, that means, let me just rewrite it to match what we have here. We have here the code for A, and followed by A equals to A plus B. Okay? So this is matching this. This comparison and jump is actually for the checking the condition for the while. If below, I will jump to A, continue, compare, and so on. Okay, right. If it is not below, that means I have to A to do the code for B. The code, what we have seen here in the assembly is actually matching, okay, what we have here in the do while loop. Agree? Make sense? Fine? Clear the idea? So you have to think about the condition very well before you use the assembly instructions. As a second example, I want also to go to our slides and to actually show you the difference between the do while and the while. So this is what we call do while loop. We have also something called the while. What is the difference between do while and while? While is actually does not have the do. I have while and then the brackets. So this statement is shifted up to replace the do. So I have while and the brackets only. How this is different from what we have seen here? Okay, here the code will be, or this loop, the code for A will be performed or executed at least once during my code execution, because do will perform the code A and then go and check the condition. If the while is replacing do here, that means if this condition is not satisfied, that means that not a single iteration will be performed here. As if that A, okay, is not below C from the beginning, without even adding B to A. So initially, if A is greater than or equal C, that means here the loop iteration will be performed at least once. But if I put the while up there, that means there is no single iteration of the code A will be performed. So this is the only difference between do while and the while. يبقى do while perform the body of the loop at least once, while only without do. Okay, as we will see in the slides, it may not execute the code for the while at all. Okay, so now I want to go to the slides. So let us just share the slides here, and let's see what we have of an example in our slides. So now I'm going to slide number, it is slide number 39. It's only one slide on the set of slides that actually discussing the while loops. As you can see here, I'm initializing actually the difference between the do while and the while is showing here. Okay, so do while perform, initialize the loop and perform one iteration of the loop. Let's just maximize the screen here. So the body of the loop will be performed once before checking the condition. If the condition is still satisfied, I will go for a second iteration for the body of the while. Here, for if I am only doing while without do, or while and do at the end, like the one that is shown here. So this is a while example, not a do while example. This is unlike the example that we have described on the board. So in this case, I initialize the loop and I'm starting by checking the condition. If the condition is satisfied, I will go to the iterations. If the condition is not satisfied, I will directly terminate and go to the code after the while. So let's go back to our example here. Here we are setting variable x equals to 12, variable y equals to 3, and here the while loop is checking whether x is greater than 0 or not. As long as x is greater than 0, I will do some body of the while here, okay? And at the end of the code, I'm dividing actually x by y. So 12 divided by 3, definitely the first division will give me x equals to 12 divided by 3 is 4. So I will go back here. I will find x is still greater than 0. I will go on to another iteration. Okay, again 4 will be divided by 3. Now 4 divided by 3 will be 1 and something, so 1 and some fraction. So I will go into a third iteration here. X is still greater than 0. Go to the body again. Now I have 4 divided by 3 is 1. Okay, where I will execute the code again. 1 divided by 3 is 0. Okay, so the while actually will check x will not be greater than 0, and the loop will terminate. This is the code for the high-level language, and here is the equivalent assembly. Remember that in the assembly we have the div instruction for unsigned numbers. So we have the body of the for loop, okay, and we have to divide here BL as 3, يبقى 12 in AX will be divided by BL, which is 3. So will give me the result of the subtraction of the division in AL, and AH will take the remainder. I want to nullify the remainder. I want to remove the remainder, so I just put zeros in the remainder. Okay, comparing the result of the division by 0. Okay, and I will here do a if it's above, okay, or equal, if they are above or equal 0. Okay, I will jump to the next. Above or equal, no, it should be above. Okay, so we have to remove the equality here, because if x is greater, I want to perform this should be jump if above only. So when we compare AL to 0, okay, I have to match this. So let me just correct that in the slides. So the slide here have a mistake. We have to remove this equality. Okay, so if it is above the 0, I will jump again. Okay, so there is no need for, so let me just save this. There is a mistake here in the slide, so it should be jump if above only. So I will correct this in the slide. Okay, so actually there is kind of a mapping between the while loop and the assembly language code. Okay, so I think that's it for the slide, or for the lecture number 19 part 2. Okay, and inshallah I will see you in the next lecture for discussing the two other high-level language paradigms, which are the if-else statements and the switch cases, in lecture number 20 part 1 and part 2.